Okay, so let's look at this question. I may skip some of the solving. I will just only describe how to. I will just explain how to describe this question. It says a frustum of a cone is cut with diameter 6 centimeter and 18 centimeter at the top and bottom respectively, and its height is 15 centimeter. So if we have a cone, let me take that again. If we have a cone, and this is our cone, then we know that its frustum was cut from this cone. So if the frustum was cut, this is, let's say it was cut somewhere here, then we know that this new frustum was the diameter. It was cut at the top at 6 centimeter. So the diameter from here to here is what? 6 centimeters. So that means we know that the point from here to here, 6 centimeter. This is our diameter. And then the one at the bottom still remains the big radius, which is our what? 18 centimeters. Then what's the height of the frustum? The height of the frustum was given to us as what? 15 centimeter. And then we are told to solve for what? Calculate the height of the larger cone. That's we're asked to calculate the height. That's the length from here, from this point to this point. So let's call it our height. Now we consider that our height would be the addition of 15 plus whatever remaining variable whatever remaining height to be here. So let's call this a particular x, since we don't know the remaining part. So we know that our height h is equal to what? 15 plus x. And this is what we're asked to find for the first one: height of the larger cone and the volume of the frustum. Now, how do we get the height? Remember, we did something like this initially. The first thing we have to first find is what the radius. And why do we look for the radius? Because we want to split this thing into right angles. We want to split into right angles at this point and at this point. And if we split the right angles, we know this, once you divide it into two, the half part will be what? The radius, right? The big radius and the small radius. So we have to get the radius of our diameter. So we know if our diameter is 18 for the big one, the radius will be half of it, right? So our big radius will be half the big diameter divided by 2, and that will be what? That will be 18 over 2, which is equal to 9 centimeters. And our small radius will be what? It will be 6 divided by 2, which is 3 centimeters. Now, after getting this, we then solve for our height. To get our height, we'll use this triangle that we've gotten. So the triangle, let's bring out the two triangles. We have this triangle. Let's say this is the small one, and this is our big one. So here's our radius. The small one, the radius is what? 3 centimeters. And the height is what we're looking for. The height is just an x. Then the slant length we don't know yet. And so let's call the slant length this. But remember, we're not really concerned about the slant length since we're solving for the height, and we can use the similar triangles formula to get our height without bothering ourselves about the slant length. Then this is the bigger slant length. The height here is what? Is h plus x, right? Which is like saying 15 plus x, which is like saying 15. Sorry, not h. That was a mistake. It was not h plus x. It was actually 15 plus x. So it's 15 plus x. And then the big radius is what? It's 9. So therefore, by similar triangles, we know we can solve this by equating their ratios. So that will be x over 3 is equal to 15 plus x over 9. And when you cross multiply, what do you have? You have that 9x is equal to 3 times 15. 3 will open our 15 plus x. So let's just do it step by step. That will be 9x is equal to 3 times 15, 45, plus 3 times x is 3x. And taking like terms, you have that 45 is equal to 9x minus 3x. Now, that will be what? 9x minus 3x will give us 6x. So we have that 45 is equal to 6x. And our x will be equal to 45 over 6. And so, what do we get? We know that 3 can divide them. 3 in 6 will give us 2. 3 in 45, 3 in 4 will give us 1, 3 in 5 will give us 3 in 15 will give us 5, and that will be 15 over 2. So we are not as 15 over 2. So that will be the answer. So when 9 minus 3, that will beat. So at this point, we continue by solving this. So therefore, if we know that our x is what 15 over 2, then we get our big height. Our big height, what's our big height? H is equal to what? Remember, it is what? 15 plus x. So our big height h will then be equal to 15 plus 15 over 2. Remember what we got at the bottom, at the downside? We got 15 plus 15 over 2. Let's just scroll down to see it. 15 over 2, so that will be 15 plus 15 over 2. Now the denominator here is 1, so that will be 15 plus, so we solve using our LCM method. So LCM of 1 and 2 is 2. 2 divided by 1 is 2. 2 times 15 is 30. And then 2 divided by 2 is 1. Times 15 is still 15. And then what do we have here? That will be 45 over 2. And that's our answer, 45 over 2. So therefore our height is 45 over 2 centimeters. And we've gotten that one. To solve for the volume of the frustum, we apply this formula. We're going to apply this direct formula to get it. I don't think I need to show that again, since I've already solved in a previous video on how to apply this formula. Remember, at this point, our height will remain the height of the frustum, not the big height, but the height of the frustum. What is the height? 15. So our small height here, h will be what? 15. Don't confuse for the big heights. Is that okay? So I would like you to finish that up while I go to the next video.